This is a solution to question number 60 on your final exam, which asked for the first three non-zero terms and the general term of the Maclaurin series for g prime of x. So basically what this problem is asking you is to derive each of the terms that you see in the given series. So when you have to do this, don't get flustered by the enormity of the whole series. Just take it term by term and derive each expression of the series one term at a time. Because a power series, or any Taylor series, is just a power series, which is just powers of x, and you know basically the simple way to derive any power function. So one of the things that might help when you're going to derive is maybe to consider or rewrite the given particular Maclaurin series. You don't want to do quotient rule on the terms of this particular series. So the second term of the series, which is 2x over 9, you can think of that as 2 over 9 times x. And the third term of the series you can think of as 3 over 27 times x squared. And the fourth term of the particular series you can think of as 4 over 81 times x cubed. Written as is, you do still have quotients in each of the terms, but those quotients are just constants. And when we go to derive those terms, we know that those constants will just get carried through to the derivative, and all you really have to then find is the derivative of the respective power of x. So, g prime of x, well, the derivative of our first term here of 1/3, that there, unfortunately, just equal to 0. So, whereas you can write that down if you like, but the problem didn't really ask for that. It wants all the non-zero terms of the series. So, moving on, the second term of the series, 2 over 9 times x, the derivative of that would be equal to 2 over 9 times essentially 1, or just 2/9. The derivative of our third term, 3 over 27 times x squared, should be equal to 3 over 27 times the derivative of x squared, which is just 2x. And then the derivative of our fourth term, well, that should be equal to 4 over 81 times the derivative of x cubed, which is 3x squared. Now, the only thing left to do is to find the derivative of this general term, which by no means is an easy task. However, when you go to find that derivative, I personally like to just derive directly from the general term itself. And that may seem like an extremely daunting task. However, you can treat it just like we treated each of the individual terms of the series, meaning this n over 3 to the n, that is just nothing but a constant. So when we go to derive that general term, that should just get carried through to our derivative. So n over 3 to the n should be a part of our general term to our derivative. Then the only thing left to do is to derive x to the n minus 1, and that's just the power of x. So, using our power rule, that n minus 1 will come down in front, and then we multiply that by x raised to, well, we just have to subtract 1 from the given power. So subtracting 1 from n minus 1, we get n minus 2. And this would represent the general term of our series for g prime of x.